Hello everyone. One more problem on 4-bar mechanism. So as I have been telling so I have been forcing you to practice and that is why I have taken another problem. For me it is not going to take much time but you have to sit and really do and practice. So a problem appeared, you already have it but anyway I am repeating it. January 2006 for 10 marks. And the problem is like this. It is a 4-bar mechanism. The MBAN. So M is the frame. So this is the MA is being called as link 2, and this is link 3 coupler, and this is link 4. Here the dimensions have been given, and every link is subjected to a torque. Okay. So out of these 3 torques, a torque on link number 2 T2, that I am supposed to find it out. How much I have to apply so that it has to remain in a equilibrium state. So when normally we don't know, normally the direction is not given, but in this problem the direction has been given. So when you calculate, so T2, your calculated value also is in the same direction, that is the value. And your calculated value is opposite to this, then you have to mention T2 as minus something. Okay, it doesn't matter. Normally the direction is not given, it doesn't bother, no problem. So T3 is given and T4 is given, the directions also are given. T3 and T4 are values here. And go to the problem, read it and then convince yourself that. So what is the value of T2 so that the mechanism remains in the equilibrium state. That is the content of the problem. Okay, it is only for 10 marks, sometimes it varies, it may be 14 marks, 16 marks. Okay, so 10 marks normally is minimum marks, depending upon only the question. Say sometimes 20 marks question, sometimes 16 marks question. Okay, it doesn't matter. Okay, this is the problem, and as usual, the first step, the configuration diagram. Okay, so go to the values of these, the dimensions of these links. Okay, I have 800, 700, something like that. And probably I can choose a scale. I cannot go ahead with 1:1, and therefore say 1 centimeter is equal to 100 mm. I should choose the scale. Okay, then the first one, Mn, I shall draw. Okay, draw a line. 800 divided by 100, 8 centimeter line. Say this is M, and say this is M. Okay, this is the frame. Okay, and then with this you measure what is called as 60 degrees. This angle is given in the problem. 60 degrees, and NA is 300 divided by 100, 3 centimeter line. So at 60 degrees you draw that. Okay, this is 3 centimeters and this is what is A. And then AB is 700 by 100, 7 centimeters with A as center and 7 centimeter as radius, you draw an arc. Please remember, whatever I am doing it is only a procedure to tell you that this is how you have to do it, and the shape, etc., the scale, since I am not doing it exactly to the scale, and therefore when you do it, you will come to know the exact shape of the diagram. Okay, then with MS center and MB, that is 400 divided by 100, 4 centimeters, you draw another line and you draw another arc and cut this and then complete it. Then probably this is how your diagram is. So this is MBAN. Okay. This is the frame. Okay. Now at every point, at wherever you have turning pair, okay, please indicate it. It is only at M, N, A, B. You have turning pair, and this is your frame. And if this line is irritating you for this, in that case probably you can keep here and you can have a turning pair here like this, and then you can remove it also, it doesn't matter if it is irritating to you. Okay, so even if you have it or you don't have it, it is alright. I hope this diagram is alright. Now then indicate what is T4. T4 is like this, and this is your link number 4, this is your link number 3, this is your link number 2, and your T3 is like this, and you know the values T4 and T3. T4 and T3, they have been given in Newton meter, the torque, but we are dealing here with the millimeter, and therefore I have converted those torques into Newton millimeter, so that when I use appropriately, then I shall get easily without any difficulty the Newton. Okay, so I need to draw lines parallel to this, etc., etc. Therefore, I am within the angle. Say this is 60 degrees. Then I shall also note down, okay, how much is this angle? Say this angle is alpha, only for my reference. Okay, then whatever may be this angle. Okay, so this is my beta. So alpha, beta, etc. Why I need it? Only to draw later on the free body diagrams. Okay, so the first step is our configuration diagram. Okay, it may appear cumbersome, but you have drawn, I hope, a neat diagram. Okay, so make sure that always the links are dark and all construction lines are very light. Otherwise, you will not be able to distinguish between the construction lines and the links. Make sure that the diagram is appropriate. Okay, then go to the second step. What is that? Drawing free body diagram. Okay, so spend some time over the mechanism, whatever you have drawn, and then find out a link which is having only two force system. So you may wonder, you don't have force here, you have only torque. Okay, the torque is created by means of force only. Don't forget, between link 4 and 3 at point B, I have a force. Between 2 and 3 at point A, I have a force. Between 1 and 2 at point N, I have a force. Every turning pole, every turning pair, wherever you have a force there. Okay, so go through each link. Link number 2, what is this? One torque and two forces. Link number 3, one torque and two forces. Link number 4, one torque and two forces. I don't have a two-force system. So therefore, immediately, no two forces link. I don't have any link for me to start with, and therefore, no two force link. That's what I conclude. So immediately, what is your conclusion? Go for superposition. What do you mean by superposition? Though you have more number of torques in this case, take only one torque at a time and analyze. Okay, like that. Repeat it as many torques you have. I have T3 and T4. Once I take only T3, once I take only T4, and then to get the effect of T3 and T4, I add the effects of only T3, only T4, and that's what I get T2. Okay, go for superposition. What is the meaning of that? Assume T3 equal to 0, and another time assume T4 equal to 0. Treat this mechanism and solve it, analyze it twice. Okay, so now I shall start with assume T3 equal to 0. T3 equal to 0. T3 equal to 0. That means link number 3 is not having torque. It is subjected to only two forces, one at A, one at B. So therefore, the first step, okay, draw free body diagram of what? Free body diagram of link 3. FBD of link number 3. So draw link number 3. How to draw link number 3? So choose a point, say this is B. Draw a horizontal line. Measure angle alpha. Measure angle alpha. To draw a line, how much length line, whatever the scale here, that line you draw it. This here. And what is this? This is very. You have turning pairs here, and you have turning pairs here. You don't have any torque. T3 is 0. Okay. So what is the force here? This is a connection between link number 3 and link number 2, and I have a force from 2 acting on 3, and similarly I have a force here acting from 4 acting on 3, therefore 3. And since there is no torque, these are the only two forces, and what are the line of action of two forces? Must be collinear. Therefore, this is the line of action of F23, which is along this line, and similarly this is the line of action of F43, which is along this line. Okay, so now I know F23 line of action, I also know F43 line of action, and let me continue now. So if I go this side link 2, T2 is unknown, therefore I won't be able to continue, and let me put here link number 4, So I draw the free body diagram of link number 4. Okay, so how do I draw? If this is point here, I draw a horizontal line here, and I measure what is called as the angle beta, and I draw this line. What is this? This is point B. At B you have a turning pair, at M you have a turning pair, and what else you have? You also have what is called as T4, which you know already, which is given in the problem. And then at M what do you have? You have what is called as F14. At B what do you have? You have force F34. Okay, F14, F34 and torque T4. So do you have any idea about F34? Yes, I have. F43 and F34, they are actions and reactions equal and opposite. Therefore, but they have the same line of action. So F34, F43, they have the same line of action. So therefore, to draw F34 line of action, you draw a horizontal line here, and then measure an angle alpha, and draw a line. This is the line of action of F34. And what will be the line of action of F14? It is a two-force system and a torque. Therefore, the two forces are exactly equal in opposite and parallel. Therefore, at F14, at M, draw a line parallel to this. This is the line of action of F14. You know it. Now we find out what is called as the perpendicular distance between the two. Okay, so let me call it as X. Okay, X4. Any notation, doesn't matter. Then what do you have? Then before I go to the value of this, so T4, what is this T4? What is the direction of this T4? You all agree that it is anti-clockwise? T4 is anti-clockwise. And therefore these two forces must form a couple in the clockwise direction, because this has to remain in equilibrium state, and this is anti-clockwise. Therefore this is like this. These two forces will form a clockwise moment. Therefore this is F14, this is F34. Therefore F34, any one force multiplied by X4 is equal to T4. You know X4 because you have drawn it. This is to scale. You measure so many centimeters and multiply by the scale of the diagram. Never forget that. If it is 2 centimeters, 2 into 100, that will give you so many millimeters. This is what I mean. X4, you have to express it in millimeter. Okay, you know X4, you know T4, which is given in the problem. So this is Newton millimeter. This X4 is in millimeter. Therefore, you find out what is F34. This is so many newtons. This is what I know. And this is also equal to F14 in magnitude. But F14 direction I already have found it out. No problem. That is all. So now I know what is F34. F34 is in this direction and this much magnitude. So if I know F34, I know F43. F34 is downward, F43 is upwards. If I know F43, I know F23. Why? Because it is a two-force member. The magnitude of this and the magnitude of this are same and opposite. Therefore, F23 I know. It is downwards like this. And now I can proceed to what is called as the second. This is FBD of link number 3. What I have done. Now go for what is that? FBD of link number 2. Okay, so choose this as N and then measure 60 degrees and draw a line, and this is your A, and at N you have a turning pair, at A you have a turning pair. Okay, so at A you have a force, so this is link number 2 and it is subjected to a torque P2. Let me keep it as if I don't know the direction. Okay, so A, then at A what do you have? You have a force from 3 on 2 at n, what do you have? You have a force from 1 acting on 2. Okay, so any information about F32? Yes, F32 and F23, they are related. They have same line of action. Draw a line parallel to this, at this point. How do you draw? At this, and as you know that this angle is the same as alpha. Okay, you measure alpha and draw this line. This is what? Look at this. This is F32. Okay, what is the direction of this? Opposite to F23. Therefore, this is F32. What is the magnitude of this? This is same as F34. Okay, therefore F32 also is known. Then what is F12? Exactly parallel to that. What is the direction of this? F32 and F12 are opposite to F12 is like this. And therefore now find out what is the perpendicular distance between the two. This is what is called as x2. Okay, what is this? F32 and F2, they try to rotate this link 2 in clockwise direction. And therefore this T2, this is not T2 final, this is T2 only small a, that is only the first problem. What I am solving is the first problem. T2a, please remember it is exactly this thing. This is what I was telling, it has been given as if it is clockwise. What is it? T2 clockwise, but T2a actually happens to be in anti-clockwise direction. You find out T2a is equal to F32 multiplied by x2, so many Newton millimeter, and in the direction anti-clockwise direction. This is what is the first part is over. Now coming to the second part. What is that second part? Now assume T4 is equal to 0. T4 is not there. So if T4 is not there, then free body diagram of link number 4, FBD of link number 4. It is very similar. Okay, draw link number 4. This is link number 4. Okay, so this is your M, this is your B. Okay, at B, what do we have? You have a turning pairs. What do you force you have? F3, 4. And what do you have here? F1, 4. Okay, these are the two forces, only two forces, you don't have anything else, and therefore the line of action of F1, 4 is along this, and F3, 4 also is along this. So you know the line of action of F3, 4. Now go to the free body diagram of, okay, B continued, the second part, and now go for what is called as FBD of link number 3. Okay, so I shall not explain how do I draw this link. This is link 3 and this is my B, this is my A, okay, all that you know. Okay, what do you have? You have what is called as T3. T4 is not, T4 is 0, but T3 is not 0. T3 is already there. Then you have B, what do you have? You have a force from link 4 acting on 3. At A, what do you have? You have a force from link 2 acting on 3. Okay, do you have any information about F43? Yes, F43 is same as F34. F43, F34, one is action, the other one is reaction, and therefore F43 line of action, F34 line of action, they are one and the same. Draw a line parallel to this. This is the line of action of what? The force F43. If F43 is like this, then how is F23? There exactly. It is a two force and a torque. The two forces are exactly opposite and parallel. This is the line of action of F23. Okay, any idea about the direction? I don't know. But T3, what is this direction? Clockwise. So the external torque, what is applied is clockwise. Then these two forces also must form a couple. In what direction? Opposite direction. Therefore, it must be like this, it must be like this. This line and this line, they are supposed to be parallel. It doesn't look here so, but make sure that these two are parallel. This is parallel to this. Then this is parallel to this. Okay, then find out what is the perpendicular distance between the two. It looks like this. This is your x3. Okay, so then F43 multiplied by x3, of course, measure this distance x3 in centimeters multiplied by the scale of the diagram 100. So in that case, this is so many millimeter is equal to what is called as T3. T3 is so many Newton millimeter. This is Newton millimeter, this is millimeter. Find out what is F43. This is so many newtons. I know magnitude and also direction. If F43 is same, then F23 also same. Direction is known. Now go to what is called as free body diagram of link number 2. Okay, link number 2. Very simple. Say this is here and say this is your A. Turning to here, turning to here. Here you have what is called as F1, 2. And here what do you have? Now here F3, 2. F3, 2 is same as F2, 3 and exactly parallel to this. So this is your F3, 2. F3, 2 direction. This is F4, 3. Sorry, not this. Of course, this and this are one and the same, no problem. The direction now F2, 3 upwards, F3, 2 must be downwards. And what about F1, 2? A line parallel to this. What is this? F1, 2. F3, 2 is like this, therefore F1, 2 is like this. F3, 2. These two together will try to rotate link 2 in clockwise direction. And therefore, the torque what I have to apply is T2B. I call it as T2B. It is only the second part. Okay. Then find out what is this distance. This x2. Okay. Then F3 multiplied by x2 is equal to T2B. And therefore, this is so many Newton millimeter. This is equal to T2B, and this also is in what direction? Anti-clockwise direction. So this also is anti-clockwise, this also is anti-clockwise, therefore resultant T2 is so much. We add physically and then put it in this direction. But in the original problem, T2 direction has been given, say that it is clockwise. What is the answer for his T2? So your T2 now and anti-clockwise and his T2 is clockwise. But you are supposed to tell his T2. What is that his T2? Magnitude remains same, but the direction is anti-clockwise. But for his T2, you have to put it minus. Or even if you don't worry about his T2, then you say that, then put it in anti-clockwise direction. You don't worry about it. That is the answer. I wish you to practice. Do well, okay, and I shall take one more session to solve one quick return motion mechanism and wind it up, okay. All the best.